For this module, these are the learning objectives. We'll explain and differentiate helper function and inner function. Inner is actually a nested function. How we can refactor a long function by extracting at least 2 helper functions to improve the readability and reduce the duplication. We'll design and implement inner functions and closure to encapsulate state and configuration, demonstrating correct use of non-local keyword where mutation of enclosed variable is required. We'll be using LEGB, which is local, enclosed, global, and built-in type of scope that can rule to predict and justify name resolution outcomes in code examples. We'll use correctly global and non-local only when necessary. We'll apply modularity principles, single responsibility, clear interfaces, low coupling to decompose complex stacks into the well-named testable function and then compose those functions into a working workflow. We will create, use, and compare the higher order functions that can accept or return functions, including practical implementation using lambdas, map, reduce, filter, and custom function factories. Then finally, after this week, you'll be learning how to implement and reason about advanced function features, closure, decorator, and lambda expression, demonstrating when each feature improves clarity, reusability, and abstraction, and when a plain def is like function or a loop is preferable. So those are the learning outcomes. Function. What is a function? Why do you need to use a function? Function is a block of code, right? And why do we need to use it? To make our code simpler. We can reuse it. It is easy to debug, easy to test, and for your future use, you can easily understand it if you're writing a code in a modular way, right? And what is the benefit of using a function? We use it, and then test it. Yeah. What else?
Easier to comprehend for people who didn't write the code or are you returning to it?
Yeah. So it is easy to comprehend. So code simplicity, right? Okay. Now we'll be discussing 2 different types of function, helper function and inner function. We already have used those type of function, but I'll be discussing in a detailed way. What is a helper function? So helper function is like helping things, right? So what I'm going to do, I need to maybe find or calculate the area of a circle. Okay. So what is my input? Here's my main function. My inputs are so that radius. Not this time, maybe 2 points. One point is the center and another point is at the perimeter. If we know the center point and the perimeter point, we can easily calculate the radius, right?
Oh, that's what, okay.
So
That's what we can make this.
center X and center Y, those are 2 X and Y point. Typically, we write those things by 0, 0, right? These are the center points. And perimeter points, it could be anything. I'm just writing like 5, 5. Okay. Now what I need to do, I need to calculate the area of a circle. What is the equation of finding an area of a circle? The pi radius square, right? So pi multiply radius square. This is the equation, right? So I can return from here. I don't know what's the value of pi. So I can either write here like 3.1415962, blah, blah, blah. I can write 142 or 14. It's 2 digit. But I don't know what is the radius here, right? Now I need to calculate the radius to find the area of a circle. That means I need some helping hand who can find the radius of the circle. So that's why I can write a function called like perimeter, the radius. Okay. Yes.
So to find the radius, we're gonna have to like use the Pythagorean theorem, right?
Yeah, exactly. So the Pythagorean theorem is like if we have like three points or what is that? What is like the horizontal line and vertical line, and there is like what's the name of that line?
Hypotenuse.
The hypotenuse. Then we can easily find the hypotenuse by square root of those two squares, right?
Do you think the import math has a function for that built in, or?
Yeah,
Right.
first thing first. So first I need to find out how I can find the hypotenuse. So let's consider those things later. Given that I can easily generate the radius. And why do you need to generate the radius? I need this radius here, right? So I'm just writing, well, radius, I don't know what is the radius, but someone is helping me. Who is helping me? This helper function, radius. So this is the helper function radius. He will generate the radius for me. I don't need to worry about it. It's like the helping hand. And what I'm going to do, I need to provide the X. What I'm going to do, I'm writing X1, Y1, X2, and Y2. Definitely, I have to have those values here, X1, Y1, X2, Y2. Right? Now, in that radius function, I have those values, X1, Y1, X2, Y2. Now come to the mathematical things. So the A square equal to B square plus C square. From there, I can easily, not this one. I can easily find the A. I cannot write the square root. So I would like to write those things in an equation so that make more sense. So this is like A square equal B square plus C square. This is like a hypotenuse. This is maybe horizontal line or vertical line. I can get the A root of B square plus C square. Right? This is the equation. And if I know X1, Y1, X2, Y2, these are the 2 points. From the coordinate geometry, I can easily find a line. What is the line equation of a coordinate geometry? If the line points are X1, Y1, Y are X2, Y2. So line equation is the same. X1 minus X2 whole square plus Y1 minus Y2 whole square, right? This is the equation of a line that is cutting from X1, Y1 to X2, Y2. I need to write the same thing to here. So the first thing is like square root. How am I going to square root? By default, Python doesn't have anything, but the math library does, or the math library has this functionality. The functionality is square root, SQRT. So what I'm going to do, I need to import the math library, and this is the square root of x1 minus y1 squared plus y1 minus y2 squared, right? And I can return from here. So I can easily find the radius from radius function. And here I'm getting the radius using the rad variable. And now I have the radius, I can easily generate the area of the circle. Now from here, I can call this area by passing the Cx, Cy, Px, and Py. So what I'm going to do, I'm calling area function. In that area function, I need the radius, but unfortunately, I don't have the radius here, just the x1, y1, x2, y2. I'm calling a function, a helper function, which will generate the radius and return it to me. And then I am calculating the area by this radius, and I can return from here. So this is the area value, and I can print the area here. Any question? Any concern? Is it a good code? Well, I haven't validated the input, given that the input are correct. Still, the validation is a part of our coding. But given that, we have a good input, like the good code here. Let me run it. Where's the problem? Check. SQRT was not defined well. SQRT is a math function, so I need to write here like math.sqrt. Other way I can write from math import all. Then I don't need to write the math.sqrt, just sqrt is fine. I told you about those two differences. Right now, I am just using so what I'm going to do here, instead of all, I'm just writing sqrt. That means from the math library, I am only taking the sqrt function. Now, whatever in the sqrt, it is here. But I can see it. With this line, I'm actually putting the sqrt function here. Since I have this function, that's why I'm calling sqrt. But if you're writing other way, import math, that means this math, we're loading the math, but it is in another module. Whenever I need to call a function from that module, definitely I need to write the module name, math.sqrt. Okay. Okay, import math. So 157.003. So hopefully it's correct. So what I have done here, I think you already have done these things before, but the name of this type of function is the helper function, though it's like a regular type of function, but it's the helper function. Why I'm calling it the helper function? It is helping to generate the radius, and I can use that radius generation in different aspects as well. For example, finding the circumference. What is the equation of finding a circumference? What is the equation of finding circumference for a circle?
2 pi r.
2 pi r. That means r is the radius, right? So maybe I'm writing a function here like circumference. I have the same x1, y1, x2, y2. What is the equation? Return 2 multiplied pi is 3.14 and radius. Yes.
Then math, we gotta replace the pi with math.pi.
Yeah, I'll come in those things later. But yeah, we can do these things. So again, I need the radius function. Like I need to calculate the radius. Do I need to create another function? I don't need to. This is the beauty of using a function, reusability. I can reuse the same functionality for different places. This particular function is just generating the radius. I can use it for area calculation. I can use it for circumference calculation. So for the circumference, I can easily call the same thing. Well, this is the radius. What I can do, I can just call it here. So this particular radius function is helping to calculate radius for both cases, area calculation and circumference calculation. That's why typically we're calling it like a helper function. Does that make sense? And when you're writing a helper function, make sure you can reuse it later for different purposes. Like area function cannot be a helper function. It's because you cannot use the area function for circumference calculation. But radius function can be used in both places. That's why it is a helper function. So for the helper function, the benefit of using is like it makes the main function easier to read. It avoids the repetition of the same code. Like if you remember here, or if you see here, if I don't write this code, this function, what I need to do, I need to repeat the code 2 places, here and here. If I am not using helper function. Though it's like one line of code repetition, but it is a repetition. If you don't practice it, probably for a big project, it can be 10, 20,000 lines of code you're repeating. For example, like input validation, you need to validate the input in different places. The same input validation. If you're not writing a helper function, then you need to write the same code again and again. So it helps you to avoid the code repetition. It makes the updates easier because one change affect all users. Like for example, I miss one thing here. Like for the radius, I need to change. Maybe the radius function just change. It is not the square root, it is cube root. Though it is not right, but for the time being, we can assume like it's the cube. So I don't need to change in 2 different places. I can only change it here, and that will reflect to both places. So you often face this type of situation when you're writing a big project code. You're changing small things, but if you're repeating the code in 5 or 6 different places, you need to find out those 6 different places to change it. Instead, if you're writing one single function and call that function in 6 different places, just change on that function only. Okay. The helper function, I already have told you why helper functions are useful. Here's an example, cleaning up the repeated logic. For example, this is a small function of finding the average of your scores. So this is a score. we have a total number, scores actually, a list. We are iterating the score. Whenever it's less than 0, we're putting it 0. When it is greater than 100, we're not exceeding 100, so it is 100. And we are just adding those numbers to total and find the average by subtracting, not subtracting, by dividing the length of the score, number of the items. Now the question is, can we use a helper function here in that particular function? Can you think of any helper function? It's very simple logic. Conditionals in a different function, right? Yeah. So what I'm going to do here, I am just creating a function called like normalizing score. So what I'm going to do here, I'm just normalizing something. Instead of writing all of those codes, 4, 5, whatever the lines of code, I'm just calling a function like normalize. I need to find out the score and sum it and then divide it by the number of items. That's it. But in between, I need to do normalization. So I need to worry about how it can be normalized. I'm calling a function normalize the score. Just normalize it. And that particular normalize function do all of those stuffs. Conditionals and all other things. I don't need to worry about it. It's a helper function. So whenever you are processing a data in a data processing the project, sometimes you need to, or maybe finding, so on your like on one of your assignments, I told you find out the word frequency from a sentence or a text. What you have done there, you just extract the word, and then from the word, you just sanitize the word from, like, if there are some punctuation, remove those punctuations. If there are some spaces, you just remove those things and all of the other things, like a normalization. So whenever you're writing a big function, your logic is very simple. I will extract the word from the sentence. From the word, maybe I will find out whether it is in the dictionary or not. If it is not there, I'll add it. If it is there, increase the frequency. It's a very simple logic, right? But you need to do all of the other things. So what you can do, you can just call those function as a helper function, and that helper function actually sanitize your sentence or word, whatever you prefer. Okay. And most of the cases, most of the project, you have used the user validation, user input validation. You can use different function, helper function, to validate those user inputs. For example, project 3, I told you to validate your inputs, like what is the initial population, what is the things, the growth rate, and iteration number, 3 inputs, and the file name. I told you to validate those inputs. So what you can do, you can just call a function like validate those inputs. You're not writing everything in the main function, just call a function, validate the inputs. In that validation function, you will do all of those checking. Well, it should be within 0 to 0.999 for the initial population. For the growth rate, it should be 0 to 3.999. For iteration, it should be a valid number. It should be starting from 0. Ending could be anything, but it is a positive number, and make sure it's not fractional. Those all of the checkings you can do in a different function, like a helper function. But the main function, you're just calling a helper function, like validate those things. It's more simpler for you to organize your code. Okay. What are the characteristics of good helper function? It is clear and narrow purposes, descriptive name, like, for example, is valid username, whether the username is valid or not. you are just calling that function here, like whether it's a valid or not. If it is not, just return the error message. Otherwise, you just return like, well, you have registered successfully here. So descriptive name. So the name itself called like, well, this particular function is validating a username and returning a true or false. If it is true, that means the username is valid. So whenever you're writing helper function, what I have written here like a radius, instead I can write calculate the radius or get the radius. I can call a function like get radius. So that this will generate the radius by calculating all of those things from 2 points. Simple input and output is because this is the helper function, and you need to write a helper function in such a way so that you can reuse it. Sometimes those helper function can be named as like a helper, process, and temp. So you can write a function called like helper. So there is no helper keyword in Python, so you can use helper as a function name. Like in our case, I'm just calling this function as a helper. That means it is helping. I don't know how it is helping, but it is helping. You can write those things. So with this naming, helper, process, temp, that makes like, well, it is a helper function. This is like a undefined convention. When to use a helper function, a section of logic is repeated. Whenever you have a repetition, definitely you need to use a function there. But helper function only using for particular helping purposes. When a function is becoming too long, for example, your input validation in the main function, it is like long main function, you can just split it to helper function. A piece of logic deserves its own name. You want to separate concern, you want to make testing easier. So testing is the important things here. So if you're, so for example, for that particular is valid input, if you're finding an error, that means there is a problem in the is valid input function. You don't need to worry about the main function. You can investigate your code in that particular function. So it helps you to test your code easier way. Some potential downsides are not every small piece of code needs its own function. If you break logic into too many small functions, then your code can become fragmented and harder to follow. So keep in mind, don't write too many functions, too many helper functions. Then it will be tougher for you to investigate or to test your code. So the goal is the clarity, not just splitting code for its own sake. Now, the second type of function is the inner function. Inner function is nothing but a helper function, but it is inside a function. That means here I need to calculate a radius first, right? So what I'm going to do here, I am writing the function inside the function. Okay. So this is our function, radius function. It is under the area function. Now I need the radius. What I'm going to do, I need to write here like, well, radius is radius. So it is the outer function, def area, and this particular two lines are inner function. And then the third line is a part of area function. In that third line, I call the radius function. The radius function is in that function. It calls that function, return the value. Then I have the radius. Then with that radius, I am calculating the area. So I cannot write this line here. It's because the function is not defined yet. The radius function is not defined yet. But I need to write the function call after the function definition. Let me run this code in Python tutor so that you can see how area. So I'm just writing here like print the area of 0, 0 and 5, 5. X1, Y1, X2, Y2. Okay. I need to import the math. So first it is importing the math. Second line, I have the area function. I need to put the area function locator there that whenever someone calls it, I will call from there. Then it goes to the main block. Print, what I need to print? I'm calling an area function. I have the area function here, locator here. I will go to there to call the area function. So next time it will call the area function. It goes to there. What are the values? 0055. I'm mapping those 0055 with x1, y1, x2, y2. x1, y1, x2, y2 is a part of area function, not a global scope. And I'll show you what is a global and local later. So it is under the area, those 4 variables. Now inside the function, I have a radius function. I have a function so that what I can do, I can put a locator there like, well, this is the locator of that function. Whenever someone calls it, I will call that locator. So I'm not doing anything, just going to the next line. Rad equal radius. So in that line, I'm calling a radius function. So what is the radius function? Here is the locator. So it will pop up to that locator. This is the radius function. It calls there. Now we need to do the functionality of that particular radius function. And what it is doing, it is calculating the radius of function by square rooting of x1 and x1 and x2 square plus y1 plus y2 square. And it is returning at the very end. You can see here it is returning. So I'm calling a function. Inside a function, I'm calling another function. So you can see here, this function is a part of area function. You remember this type of notation in your math class? Function of fx, then function of g of x, then function of g of m of x. We can write it like, we can write these things like f of gx, f of g of m of x. Do you remember this type of notation in math class? The function within a function. So this is like inner function. So I'm actually calling f, function f of what? G of x. So g of x is the inner function. So I need to do the g of x first. What is the g of x? Whatever it is. So f function is doing like x squared. G function is doing like x cubed. And the x value is like, for example, 5. So it goes to the x cube first. That means 5 of cube. What is the value of 5 of cube? 5 multiply 5 multiply 5. So 25 multiply 5 is like 125, right? So g of x is returning 125. So instead of g of x, I need to put 125. F of 125. And what is the f function? X squared. The x value is 125. That means 125 out of 2. That means 125 into 125, whatever the value. So whenever there's the inner function, we need to finish that particular operation first. Then you need to go back to the outer one. Just like our loop. If it is a nested loop or inner loop, we need to do the operation of inner loop first. Then we'll go back to the outer loop. So that's what it is doing. For the area function, inside the area function, I have a radius function. I need to calculate the radius first until it is returning. Whenever it is returned, that means we're done with the inner function. Then we can work the next line of code. What is the next line of code? Just the return. But we can have a different statements here between radius calculation and return. Since we don't have any, so we're just returning from here. Does that make sense? Inner function. Now for the inner function, one good thing is I don't need to use this x1, y1, x2, y2. But still we don't have any error. If we don't use x1, y1, x2, y2, we don't have any error. We're using x. So think about this function. So let me go to the Python tutor so that it make more sense. Okay, this is a math import area locator calling the area. I have x1, y1, x2, y2. Radius is the locator. It will put the locator here. Then go to the radius function call. When we have the radius function call, it goes to the radius. You can see here the parent f1, like f of x of f of g of x. So this is our g function. And inside the g, it is inheriting everything from the x. So in the x function, I'm sorry, f function. So in the area function, we have x1, y1, x2, y2. By default, it inherits all of those values. So these 4 values are the part of the radius function as well. We don't have any error. It calculates the square root of those values. I can easily calculate the radius and return the result. That means whenever we have an inner function, the inner function easily inherit the variables from the outer function, just like a global. So this is a global for the area function, and these global things can work inside the radius function. So the benefit of using inner function is we don't need to use the variable declaration again and again. We can waive those things here, like just nothing in the radius, just nothing. And this is particularly called like enclosed type of scoping. I'll be discussing later today. This is called like enclosed scope. Whenever we're declaring a function, those particular variables has the scope of local. You cannot use the x1, y1 outside of the area function. That's why they are local. But this type of thing is like an enclosed, like if something inside the area, like as I told you, the 4 variables has the scope inside the whole area function. That means whatever we can write inside the area function, it has the scope. I can access the x1, y1, x2, y2 from the radius function as because this particular 4 variables is a part of area, is a part of radius as well, not the radius. Does that make sense? Can anyone tell me what is the demerit point here of using an inner function? In that particular code? Well, the merit is like, well, I don't need to use the variable again and again. Go ahead, Stephen.
I was gonna say with this one, you can't use radius outside of the area.
Yes.
You can only define inside of there.
Catch. Exactly. I cannot use the radius function outside of the area. That means with this circumference calculation, I cannot use that radius function. That means I need to write the same radius function here. Like the code repetition, right? I cannot use this radius without calling it. I have an error. It's because this radius is a part of area function. It is not a separate function. It's a part of area function. I cannot use the radius function by calculating the circumference. But fortunately or unfortunately, to calculate area and circumference, I need to know the radius. In that particular case, inner function is not helpful. Though we have some merit points, like I don't need to pass the variables. Variables typically take some memory location in our memory. We can save some memory, but for the sake of memory, we are writing the same function definition again and again. Though it's like one line of code, it can be multiple lines of code. In that particular case, inner function is not helpful, but helper function is. In the helper function, I can just call a helper function here, or write a helper function here, the radius. Instead of calling this one, I can call the radius function. But well, I need to pass the parameter to there. I already have written two different types of function here, helper function and inner function. And I'm just discussing about the merits and demerits points of helper and inner function. Inner function is helpful whenever you have a short line of code for a functionality and you're not repeating it. If you're repeating it, that means the inner function is not helpful here. It's better to use a helper function. If you're trying to save some memory, well, inner function is helpful, but helper function is not. But at least you need to know all of those type of things. Any question about the helper function and inner function? No? Okay, so inner function is only defined inside an outer function that I have told you. So our outer function was area and inner function was radius. Why it is helpful? One important thing is like encapsulation. If a function is only needed inside one another function, defining it inside the private and avoid the cluttering the global namespace. So what we're going to do, we're making that radius calculation as a private function for the area function. We're not using it. So this particular feature is called encapsulation. We are using encapsulation mostly in a class, like object-oriented programming, whenever we're using class and object. Right now, we are not discussing about the object-oriented programming, but it's like a functional programming. It's like a function flow, or we can say it's like procedural programming. We're writing function, it calls the function, we're doing that particular task. But in an object-oriented programming, the functions are in a private mode. They are encapsulated. We'll be discussing those things in module 13, but I'm giving you some heads up, like encapsulation can be occurred in functional programming whenever you are writing a function within a function, like an inner function. You can write some logical grouping. Inner function keeps related logic close together. For example, you can write two inner function in a big function. So what you can do, initially, what you have done before, in a main function, you have written everything. Everything means like everything in a main function. Not everyone, but some of you have done these things before. You have written area function in a main function. Radius function, well, it's a 3 level of inner. In a main function, you are writing many more inner function. And I don't know, maybe it was an honest mistake, but someone may have done those things for the reason of like, well, this is the functionality of calculating area. This is the functionality of calculating circumference, and everything is in the main function. So you can separate the functionality in two different places. You could write inside a function. You could write outside of a function. I remember one student from a different section where I told you do not use a variable. I'm sorry, do not use a variable in a global scope. That means here is your input. You're getting the input from the user. So input may be like operand 1 and the operand 2. I told you, do not use those operand as a global scope. It should be inside the main function. Well, if you're writing here like an add function, and if you need to find the operand 1 and operand 2, definitely you need to call a function by passing the parameter. So some of my students did the other way. What they have done, put the operand 1 and operand 2 here so that they are in the global scope. And then instead of calling add function, they don't need to pass the operand 1 and operand 2. It's because the operand 1 and operand 2 are the global. I can easily find operand 1 from here, operand 2 from here. But I told them do not use a global scope. That's why I told most of the project, like, do not use any global code. That's the reason. You need to know how you can use a function parameter passing and function like a parameter and what's the other name? Forget the other name, whatever. The parameter. You need to know what is the parameter, how you can pass the parameter. Now, if you're passing the parameter here, then probably you don't need the global code. But some of my students are really clever. What they have done, I told them do not use the global code. They didn't. What they have done, they have written inside a main function and write the add function here. They satisfied the rubric. They didn't use the global code. So what they've done, I don't know. So what is purposefully or unpurposefully, but it worked. A function within a function. The add function is inside the main function. They have using the operand 1 and operand 2 here, but they didn't learn how to use the parameter passing to avoid the global code. So my purpose didn't serve. I told them do not use the global code. They didn't. My purpose was to teach you like, well, you need to use the parameter passing, but they didn't. But this is the another way. With that particular way, you have learned a different technique. You are avoiding a lot of things, but you have learned a different technique. What's the technique? The inner function technique. Okay. But when I ask them, can you verify your code? Can you clarify your code? What type of code it is? They don't know. I told them, well, you'll learn those things in week 11. It's like an inner function. You have used the inner function. It worked, but you don't know it is an inner function. And what is the purpose of inner function? Okay, so that's why I mentioned like logical grouping. If you're putting logical things one after another, you can put everything in a function as inner function. Access to the outer variable, this is the important things. If you need to access the outer variable, probably for that particular cases, they have used this type of function. I told them do not use the global code. To access the outer variable, they have used the inner function. This is one of the reasoning. Closure. Inner function can remember values from the outer scope even after the outer function has finished running. I'll discuss the closure later. Here's the case, keeping the helper logic local, like add text. Maybe the text calculation is only for the calculate the pricing. I don't need to write the add text in the outer function. If I'm writing this helper function in the outer place, maybe it is tough for me to find out whether it is a final price tax or sales tax or other types of tax. That's why I put the tax information inside that final tax, final price calculation, so that I'm making the logic inside that outer function. So sometimes you write this way. Okay. I'll discuss closer later. Then function modularity. Yeah, well, the purpose of writing a function is like module, how you can module your code. You have written a naive code, like our very first project. What is that? What's the name? Mira and Toph calculation, a share calculation. You have written your code in a plain text, just procedural language, one after another. It will run one line and next line and so on and so forth. Then you have module your code. Like this particular task is for Mira's calculation. This particular lines of code are for the Top's calculation. And this is for a general crew calculation. And finally, another task is for printing the result. Maybe there is another module at the very beginning is like getting the input. So there are like a lot of modules. Then from that base code, you have written different types of functions, like code modularity. And why did you do these things? The reason is it is easy to understand, easy to modify. And whenever you're testing, for example, your Top's calculation is not correct, you don't need to worry about the whole code. Just concern on the Top's calculation function. I have an error in that particular location, so I don't need to worry about the whole code. But if you're not writing a modular code, probably you need to investigate the whole code, what I have done wrong. Or maybe the input is wrong, so you don't need to worry about the rest of the code, just the input, just concern on the input functionality. Or I told you, you haven't followed the exact rubric for the output. That means there is an error for the output. You haven't used the F string, or you haven't used the 2-point like precision things. So I told you your answer is correct. That means you don't need to worry about the other function, just the output functionality. You can follow on that particular function and just think about, well, what I missed these things. I can fix it. Okay. Well, it reduces the complexity. It improves the testing that I had just told. It improves the teamwork. For example, in a big project, one part is for, like, for example, I have a project like a ride sharing app. So in the ride sharing app, multiple people are working in different modules. One people is working with the user management. One people is working with only the ride calculation. Another people is working with the tax calculation. So it is easy to work in a team. Like if I have an error in a tax calculation, I don't need to worry about the other team. Like, well, the users management is fine. There's no error. There is an error in the tax calculation. I can talk to the other team. What they're handling is because they have a different functionality. I don't need to change everything. I don't need to investigate the whole code, just the particular code. So it helps to improve the teamwork whenever you are doing the modularity. And as always, function is for the reusability. Whenever you're writing a function, one of the intention is like you are avoiding the code repetition. Well, here is a non-module code. What they're doing, they're just processing an order. Here's our order quantity plus multiply the price. We have a discount, tax item, total price by discount, like subtracting the discount plus tax amount, and finally printing the result. Like, well, this is the subtotal, this is the discount, this is the tax, here is the total. It is okay. It's like few lines of code, but in a real world scenario, it cannot be that simple. It can be bigger thing. Like in an order, not necessarily it has like price and quantity. It may have images. It may have, for example, you are looking for a t-shirt. It could be different sizes. It could be different colors. It could be different vendors. A lot of information, right? That means the code is like bigger code. Then for the like price calculation, it can be different. For example, if you are an Amazon Prime customer, if you have different pricing things. If you're not, that's the other thing. You have to purchase at least $35 to get the discounted price. Sometimes they're giving you some discount for the Amazon employees. A lot of the things here. And finally, the result, like another result is like the printing things, like the output. It can be a PDF output. It can be a regular invoice. It could be an email confirmation or text confirmation, a lot of other things. So in a real world scenario, it can be different. So now if we are going to module this code, what can be the first approach? The first approach is like, well, here is my subtotal calculation. Here is my main total calculation, and here is my result. The result means like my output. At least 3 modules I can think of it. You're right? Then maybe in a bigger project, maybe discount is a different module. Tax calculation is a different module, is because there are like different types of taxes in different states. For example, Utah tax and California tax are not the same. Or maybe in an Utah, different city has like different taxes. Salt Lake City has a different tax. St. George has maybe different tax things. For the total calculation, it can be different module. So right now I can think of only one module for this calculation. But in a bigger project, it can be varied. So that's what they have done. For the processing order, they are calculating the subtotal. Maybe it's a simple line of code. It's a subtotal. Calculate the discount. From the discount, I can calculate the taxable amount. Then I can call the calculate tax with that taxable amount and the tax rate. Find the tax. Then I can create a build order summary, like an output, a PDF or a printout. So I can just write how many lines of 3, 3, 6, 9 lines of code in like 4 different functions. Each of the, so I don't need to worry about those things here in the process order. In the process order, I can say, well, what is the subtotal? Maybe a particular team is working with the discount. So if there is an error in the discount, I don't need to worry about the other lines of code. I can call that team. Well, hey, what is the problem with the discount? You are giving the 100% discount. That's how we are losing our revenues. Well, this is my very last day. That's why I'm giving 100% to everyone. Well, maybe this is your last minute then. Right? So that's why it is more easier for a teamwork. For a tax rate, a lot of people try to like purchase their car in a state where they don't have any sales tax. It's okay, but when they're coming to their home state, they need to pay the tax. So there can be different things, how we can calculate the tax. So they're saying, well, it's not our end things, it is like a state things, the tax calculation, that's fine. So that particular department can work with the tax. So I don't have to worry about these things whenever I'm calculating, whenever I'm processing an order. So that's why I'm writing a modular way. So each module is responsible for a particular task. So tax module is not responsible for the discount. So whatever the discount issue, talk to them. I'm not worried about the discount thing. So only tax related information is concerned in the calculate tax module. So we're just assigning some responsibility, specific responsibility to those modules. This is the beauty of using a modular work, teamwork, or managing a big organization. So if there is an error, for example, like the Amazon server is down, so not all of the employees are responsible for Amazon server down. Some particular team is responsible for this one. So you cannot sue everyone, or you cannot fire everyone. You can just fire those particular people. Okay. Okay. How much time we have left? Well, modularity is good, but sometimes, well, single responsibility, clear interfaces, separate of concern, reusability, independence. So for example, like discount team is independently working on the discount thing. So they are not involving anything with the other part. So a lot of the people are independent on their own part. So that's why they're responsible on their own part, and that's why they're independent. So we can put those functionality, those module in the independent way. But sometimes when you are doing a lot more modular things, it can be a poor example of modularity. For example, like this one. Each line of code is a module. Handling a data, clean the item, unique the item, sort the item, and sorting the result. No, not this one. The modular version. Example of poor modularity. So actually there is no module here. That's what I told, like too many responsibility for this particular function. Handle the data. Handling the data, doing everything, like process the order. If I'm running everything in a one single function, this particular function is responsible of doing everything. It is clean, but sometimes there's some duplication. What's the duplication? See any, but maybe you can write some duplicate here, but you can write a modular version where you are separating the responsibility to different parties. But there's some example of writing too much here. Some potential danger is like over modularization. Modularity is useful, but can be overdone. If a program contains too many tiny functions that do almost nothing, the reader may have to jump around too much to understand the flow. It should be balanced, decomposition, readability, and practicability. Function composition, the last part of today's lecture. I already told you about the function composition previously. Function composition is like calling a function within a function. Calling a function within a function. I'm calling a function print another function area. What it is doing? F of x of g. So it's f of g of x. That means I'm calling a function fx. Inside the fx, there's a gx. That means I need to find the value of gx and then process with the fx. The same way, I need to call the area function first, which will generate the area. Whatever they're doing, I don't need to worry about it. But whatever the value, I'll print it to the terminal. So this particular things is called like function composition. And as I told you in the function module, if your function composition is like too many function in a function call, it is harder for you to investigate like what's the problem, like 4 or 5 function call in one function. Then you never know what is the problem. So too many things is not good to anyone, not in modularity, not in functionality. So here, what I just mentioned, f of g of x. First, apply g to x, then apply f to g. There's some example here. It encourages small function, predictable behavior. For example, I just print the area calculation, reusable logic. It is especially useful when functions are pure. What does it mean by the pure? They do not change the outside state and always return the same result for the same input. So for example, like this one, I'm calling a function called like remove exclamation. In that remove exclamation, I'm calling toLower. In the toLower, I'm calling the strip text. Basically, it will call from here in the very bottom, the very inner one. So strip text will remove the spaces and new lines or all of the other things. Then whatever the value, so I told you this should be, they do not change the outside state, they return the same result for the same input. Like whatever the text, I'm just removing the spaces. Now, at this point, I know there is no spaces. So if I'm putting it lowercase, it may not change to anything. Now, to that lowercase, whatever I'm putting, it will convert to lower. So I have a function here. I'm passing that particular value that are given from strip text. I'm putting that value to that function, toLower, and toLower returns .lower. That means lower cases. Now after that, we have a text. Everything is lower, right? Like everything is lowercase. Now I am just putting that text to the remove exclamation. In the remove exclamation, this particular text is like all lower, but I'm not worrying about some exclamation or other things. Now it is time to replace an exclamation with nothing. So in that particular example, if we're putting this text to here, strip text, remove these spaces and that spaces, but this particular value to two lowercase. In the two lowercase, it just convert H and W to L, and all of the other things are like lowered one. And exclamation is as it is. Now to the remove exclamation, it goes here, and whenever it finds an exclamation, it replaced with nothing. And finally, we'll have hello world with small letter cases. So it is easy to understand, but if it is like 10 function calling one inside another, it is tougher for you. I would suggest not more than 3 function calling is good for a function composition. At most 3. If you have 3 function calling, you can investigate it, but if it is more than 3, it is really tougher for you to investigate. Okay. But yeah, in next class, I'll be discussing about the scopes. What I missed, what Lucas said, like about the high things, I'll be discussing those things in the next class. Okay. Any question at this point? Helper function, inner function, function modularity. We already discussed the function modularity in the function. Again, I have discussed here, and the function composition. So the next class I'll be discussing. So there's a lot of function composition here. All together, like composition and modularity. Here is like modularity, and function composition is like, well, I can write. Let me investigate from here. Run text pipeline with the entry. I'm calling a function, process text entries. This is basically helper function. And in that particular function, I'm doing some list comprehension. I'm calling another function helper. So you can see here helper function. Starting from here, process text to the process text, there's another helper function. Remove duplicates. In the remove duplicates, it is calling a function within a function, like function composition. It is converting whatever it is, converting to set, converting to list. Can anyone tell me what it is doing here? Come on.
Creating and ascending items from this section.
New item of list. Basically, it is removing the duplicate by converting to set, right? Whenever it's a set, removing the duplicate, we have a list here, converting to set, and then converting back to the list. So list, set, list in between this pipeline. So this is called like function composition here, and here's the helper function all together, modularity and function composition. Okay. You can read those things here like best practices, what are the mistakes and understanding. I'm not going to discuss everything here. Any question at this point?